The topic of this video is identifying polynomial functions and their degree. Let's look at a problem. Is the function a polynomial? If so, state its degree. If not, why? We're given two functions, g of x and f of x, and I've written over here just a shortened version of the definition of a polynomial. A polynomial is any function that can be put in the form box plus box x plus box x squared plus etc., where each box has a real number. Now let's just briefly state what a real number means. A real number is any number that would be a counting number or a whole number or an integer or a decimal or a fraction or even an irrational number like e or pi. Pretty much a real number is any number that's not complex or not undefined. Just about every number in the world is a real number, at least the ones that we would deal with in an algebra class. It's very rare to see numbers that are not real. All right, so here we go. Let's go ahead and solve our first problem, g of x. Our job is to take what we are given and try to put it in this form. Notice that we have a fraction, and specifically our variable is inside the fraction. We need to get it out of there. All right, so let's go ahead and do this. We're going to perform the division. We're going to divide each part of the numerator by the denominator. So the first piece is going to be pi over 8. The second piece is going to be x squared divided by 8. And this minus sign will come in between our two fractions. Now the coefficient of this x is 1. This is the same thing as a 1x squared. So if we want to get this x, and specifically the x squared, outside of our fraction, we have to use a property of fractions that says if you have a factor in the numerator of your fraction, you can actually move that to the right. So this is going to be rewritten as g of x equals pi over 8 minus 1/8 x squared. Now all we have to do is put our terms in the correct order, which would be the order of this definition. And so the first thing we want is a number that goes in this box, the constant term. That's the term with no x in it. Well, we already have that. That's pi over 8. Not only is it already there, it's also in the correct order. All right, next we want to be able to put a number here for the term that has just x. We don't have any of those. This one has no x, this one has x squared, so we would have to put a 0 in that box. And then the next one is a box times x squared. Well, that would in this case be a negative 1/8 is the number that's multiplying by the x squared, etc., etc., etc. We don't have any more terms. So were we able to take our function g of x and put it in this particular form? The answer is yes. And so for that reason, this is a polynomial. The degree is the highest exponent of x needed to write the polynomial, which in this case is 2. So this is the leading term, negative 1/8 x squared. This is the constant term, pi over 8, and this is a polynomial of degree 2. Okay, let's go ahead now and move on to our next function. F of x equals 4 minus 5 over x. We're going to use a property from intermediate algebra here. We need to make sure that x is no longer part of a fraction. In intermediate algebra, we learned that a to the negative n is the same as 1 over a to the positive n. Now, these letters are arbitrary. I could just as easily write it as x to the negative n is the same thing as 1 over x to the positive n. Notice that I have an x down here in the denominator with no printed exponent, which means the exponent is 1. So if I replace both of these n's with 1, I get x to the negative 1 is the same thing as 1 over x to the positive 1. And of course, this 1 is not necessary. I can remove it. This gives me a very important tool which I'll need when solving this problem. 1 over x can be rewritten as x to the negative 1 power. All right, let's go ahead and solve this problem. Here we go. So I'm going to write 5 over x as a product of fractions. I'm going to write it as 5 over 1 times 1 over x. And I think you'll agree with me that this product is equal to this fraction. 5 times 1 is 5. 1 times x is x. Now the reason why I'm choosing to write it that way is I'm trying to create this 1 over x here so that I can use my algebra rule. So now I'll have f of x equals 4 minus 5 over 1 is just 5, and 1 over x is x to the negative 1 power. Okay, so now that my x is no longer in a fraction, I'm going to attempt to take my f of x and put it in this form. So in the first box, I would put the 4, since that's the term with no variable. In the second box, I look for a term that has just x with no exponent. I don't have one of those. And then I look for a term that has just x squared with no exponent, and I don't have one of those. And I could do this over and over and over and over. The problem is that this term here would never find its way into our form, and the reason why is because of this exponent of -1. So for the reason specified, this exponent of -1, this f of x is not a polynomial. A polynomial is not allowed to have a negative exponent. All right, so there we go. We have solved this problem. Let's just briefly summarize. G of x was able to be rewritten in this form, and therefore it is a polynomial of degree 2. F of x could not be rewritten in this form because getting the x outside of the fraction meant revealing that there is a negative exponent, which is not allowed based on the definition. Therefore, this was not a polynomial because of that negative exponent.